Well, actually, I started out as a theoretical chemist, so I come from sort of the laboratory side, and I've worked a lot on photodissociation processes. But over the years, I've more and more become involved in observations, and especially with the latest instruments, such as the Herschel Space Observatory, and now, of course, ALMA. And there we are seeing just fantastic new things in terms of astrochemistry. So over the past 10 years, a lot of my work has focused on water. I mean, thanks to Herschel, of course, we've been able to observe water in space uniquely above the Earth's atmosphere. And we've learned so much about water, how it's formed on the surfaces of grains, how it is desorbed both by heating but also by UV photons. So as a chemist, I thought that everything was known already about water, that we could just look it up in the chemical physics literature. But that was not at all the case. So much more in terms of laboratory experiments has been done in the last decade, even on a simple molecule like water. The next step is obviously chemical complexity. And thanks to ALMA, we are able to go from relatively simple molecules like methanol to ethanol, but maybe also 3-carbon molecules like propanol. So I think that's really the next stage, is that we are starting to build up this complexity, for example, in the number of carbon atoms on the backbones. And then we get really into the regime that we can start to compare our abundances with those that have been observed, for example, in comets. It's actually a very fortunate coincidence that ALMA has come online and started to produce beautiful data at the same time that we had the Rosetta mission, the landing on the comet surface, but also the mass spectrometer in orbit, Rosina, which has measured this whole suite, a whole zoo actually, of complex molecules. And so I think this is one of the exciting parts, that we are now really able to make sort of a one-on-one comparison between what we see in interstellar clouds, in the regions in which stars are forming, in protoplanetary disks. And then we are able to take that sort of to smaller and smaller regions. We're able to zoom in with ALMA, and then ultimately we get to the comet forming zones, and then we can sort of make that link directly.